advising session?
Come on in. What can I do for you guys today?
Well, I'm deciding between majors and I want to know more about chemical engineering.
Isn't that just chemistry?
Actually, that's a common misconception. Chemical engineers do a lot more. We design or optimize processes that synthesize, convert, or transport raw materials into finished products. For example, chemical engineers are responsible for the functioning of this oil refinery.
How does the refinery turn crude oil into gasoline?
That's a great question. And guess what? It can all be explained with this really simple equation. In minus out plus generation minus consumption equals accumulation.
That seems like a simple equation for a really complicated task.
Hear her out.
This equation is the basis of what we call
material and energy balance.
What's that?
It's the method chemical engineers use to keep track of everything in a process. Kind of like bookkeeping. You remember the conservation of mass and energy laws from your physics and chemistry classes, right?
Yes.
Material and energy balances are based on those principles. What goes in must come out. So a lot of chemical engineering is really just a big algebra problem. For example, the engineers at this oil refinery use material and energy balances to separate the components of a barrel of oil.
That looks like a total mess.
Again, it's really not. As you can see, an oil refinery just needs a lot of equipment to separate, convert, or purify things. There are distillation columns, which separate the lighter components from the heavier components in the crude oil. This means that the lighter molecules, like natural gas or methane, come out at the top, while the heavier components, like lubricating oils, come out at the bottom. Once the components are separated, they get sent to other pieces of equipment for purification, like absorbers, stripping columns, or membranes. Component streams can also be sent to other units for further conversion, like a catalytic cracker, which converts heavier hydrocarbons into more valuable, lighter hydrocarbons like gasoline.
But wait, how do you get things between all these process units?
Great question. In a refinery, fluids are transported between process units and pipes, so chemical engineers need to know a lot about fluid mechanics in order to ensure that everything in a refinery is transported as smoothly as possible.
This must take a lot of energy.
It does, but chemical engineers can find ways to decrease the energy input. Look at this simple heat exchanger, which is extremely common in oil refineries. A hot fluid can be passed through a pipe, which transfers energy to a colder fluid in a different pipe. So you're conserving energy by using a fluid that's already hot to heat a different fluid. A huge part of a chemical engineer's job is making sure that everything is run as efficiently and economically as possible.
So, after all that stuff goes through the refinery, it ends up as gas and diesel, we put it into our cars, right?
Yes, but not just that. The petroleum products that come out of a refinery are not only used to make gasoline, but also jet fuel, asphalt, Vaseline, crayons, soap, detergent, fertilizer, plastics, like those in your smartphone or calculator, and even clothing.
One last question. It seems that a refinery can be really dangerous. Is it safe?
Good question. Safety is really important, especially in an oil refinery where units operate at really high temperatures and pressures. Look at a picture of our friend Kelly working at the BP refinery. She's wearing fire retardant clothing, gloves to protect her hands, a hard hat, safety glasses, and a microphone in case she needs to call for help. You can't see her feet, but she's also wearing steel-toed boots.
Wait, you have to wear all that for safety? That seems pretty excessive.
It's not. Safety is the first priority in any working environment. But don't worry, it becomes second nature to a chemical engineer. Then you can concentrate on the job at hand, whether it be refining oil, making plastics, processing food, or any other of the millions of things you can do with a chemical engineering degree.
Thanks. Chemical engineering definitely seems really interesting.
Yeah, if you'd like more information, go to www.aiche.org. You can find out what companies to work for, your typical salary after college, more safety information, and much more.